Okay, we did vertical shifts. Now we're going to look at horizontal shifts. This is the other one that's usually not too bad. Horizontal, anything done vertically is done to the function, the y values. Anything done horizontally is done to the x values. Right? Vertically would be the y-axis up and down. Horizontally would be the x-axis left and right. Alright, so horizontal shifts are when you add or subtract to the x value of the function. So inside the function, you're going to add a number to all of the x values. And so that's literally what you do. On the original graph, you add or subtract whatever that number is for every single x value on the graph. Right, so again, I'm going to stick with the simple quadratic case. So my original function was that f of x squared, which these were the points that it had on it. Alright, so it was the points negative 2, 4, negative 1, and again I have the graph down here that we're going to use. And then I'm going to do shifts. I'm going to do horizontal shifts left and right. Alright, and the tricky part, horizontal ones are the tricky part because it's counterintuitive because I have to overcome what I added to get back to the original value. So my original points, remember, were negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Right? Those would have been the graphs. And so this time the y values are staying the same. Whereas on the last graph, it was the x values that stay the same, it was the y values that changed, because that's what we did, we changed the function. This time, it's the x values that are changing, the y values are going to stay the same. And so to get to my same y values, I have to add or subtract by the corresponding shift, by the corresponding value. And so, when I add inside, I actually need to subtract to get to the value. So to get back to the 4, the 1, the 0, the 1, and the 4 case, right? That's what these numbers should come out. My y values that should pair should go the same. These should be the same. What's different will be the x values. It's the opposite of what happened in the vertical shift. The vertical shift, the x values stayed the same. The y values changed. Well, in this case, the x values changed, the y values are staying the same. Alright, so the x values are going to change. And so in the first graph, my g of x, so my g of x is where we're adding 3 to the x value. And so when we add 3 to the x value, so when we're inside and we're adding, well, we have to overcome that additional 3 for the x value to get to the same y value point. And so in this case, it's going to be a left shift by 3 units. I'm going to move my whole entire graph to the left 3 units. That's the negative direction. I've got to move it in there because what I'm doing, the best way to think about it is I want to get back to my 0, right? If I want to get back to the 0 case, which is the 0, 0 point, I can't plug 0 in to get back to 0. Well, what do I have to plug in to get 0? I have to plug a negative 3 in. Right? And so I had to move in the negative direction by 3 units to get to that negative value. And so when we add by 3, we actually want to subtract. So I'm going to write that a little different. So we're going to shift to the left by 3 units. And every x value you're going to subtract by 3 units. That's what I have to do to get back to the original y values. And so that's what I've done here when I set up my table. My original x value is negative 2. Well, I'm going to subtract 3 from it to get negative 5, which means when I put that negative 5, I should get a 4 out. And it does. If I put negative 5 in here, I get negative 5 plus 3, which is going to give me negative 2. Negative 2 squared gets me 4. And I got the 4. Same thing for the next one. My x value was a negative 1. Well, I need to subtract 3 from it, so now it's a negative 4, which still should put me back at the same y value 1. And it does. When I plug 4 in, I get negative 4 plus 3, which is negative 1. Negative 1 squared is 1. This should give me my 0 out. And that's the easiest place to tell what's happening. Right? I want to get 0 out. Well, in order to get 0 out, I have to put negative 3 in. Right? I put negative 3 in, it zeroes away. And then so the same thing, this is going to be 1, this is going to be 4. And so my function values stay the same. It's the x values that have to shift. because it's the x values that I'm changing. And you'll see that that's what happens when I go to graph this, alright? So all of my x values, I have to undo the adding by 3. That's another way to think about it. I added all of my x values by 3. To undo that plus 3, I have to move 3 units to the left. I have to subtract 3 from my entire function. And so when we go look at this, we graph those points. So my points that I'm going to graph for my g of x, so again I'm shifting to the left 3 units. And so all of my points get moved over by 3. So 1, 2, 3. So that's going to put me over here at negative 5, 4. And that is the point I'm at. 1, 2, 3. That's going to put me at negative 4, 1. That's the point I'm at. 2, 3. That's going to put me at negative 3, 1. And that is, again, where I'm supposed to be. Move that over 3. That's at the point negative 2, 1, which is where it should be. And now that's at the point negative 1. Right? And so all of them match up, negative 1, 4. And so this green graph is that function g of x. They're all been shifted to the left 3 units. So my g of x is my f of x function, where I've added 3 to the x value. Alright, so I've taken x squared and I've put a plus 3 on the x part. So instead of x squared, it's x plus 3 squared, right? And there's the new graph, the green graph. Well, something similar happens when we subtract, alright? So now the subtraction case. Alright, so f of x was my original. Now we're subtracting by 4 inside. And so in this case, everything's going to shift to the right by 4 units. The easiest way is to look at the 0. If I want to get back to the 0, well, what do I have to plug in here to get 0? I have to plug 4 in there to get my 0 out. And so I had to add 4 to get back to where I was. So I shifted to the right, the positive side, 4 units to the x values. Alright, so I'm shifting to the right by 4. And so that's what's going to happen. So I get all of those same numbers back. 4, 1, 0, 1, 4. And you can check and make sure. If I plug 2 in, right, I'm going to get 2 minus 4, which is negative 2. Negative 2 squared is 4. When I plug 1 in, I'm going to get, or sorry, when I plug 3 in, I'm going to get 3 minus 4, which is negative 1. Negative 1 squared is 1. 0 gives me out my, so 4 gives me out my 0. 5 gives me out 1. 6 gives me out 4. And so it does match. So all of my new points, x has been added by 4. All of my original x values, I add 4 to them. I keep the same y values. And if you go look, that means we shift to the left, or sorry, the right, shift to the right, 4 units. So every single point gets shifted over 4 units. Alright, that one's off my page, so I'm just going to mark it off there. 1, 2, 3, 4. So that's at the point 5, 1. This would have been at the point 6, 4, that's what came from my table. That would have been at the point 4, 0, right? 1, 2, 3, 4. That's the point 3, 1. And actually, it's there. That's the point 2, 4. And there's my red graph that represents h of x, where I've been shifted over to the right 4 units, right? H of x, which is x minus 4 squared. And if you graphed it on your calculator, that is what would come out. So when I add to x values, I shift to the left by that amount. All of my x values get shifted. When I subtract the x values, I shift to the right. Right? So add to the left, subtract to the right. Right? On the x value, so inside the function, right? I'm putting stuff inside the function, right? It's the x values that are affected. So when I add inside, I shift to the left. When I subtract inside, I shift to the right. And that is my shifts, my horizontal shifts.